Okay, here's lesson 21 for 7th grade, and today we're talking about prime and composite numbers, and then we're also going to incorporate prime factorization. So we're going to figure out how to find the prime factorization of composite numbers later. So here are our main goals for today. In this lesson we will learn 1. How to identify a composite number. Number 2. How to identify a prime number. And lastly, like I said, we're going to figure out how to break down a composite number into its prime factorization. Alright, so first things first here. We remember that the counting numbers, or natural numbers, are the numbers we use to count. And they are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth up into infinity. We always start with 1 when we count, so this set does not include 0, remember that. We're going to use those for figuring out what prime and composites are. So, counting numbers greater than 1 are either prime numbers or composite numbers. So I've highlighted the important things here. A prime number has exactly 2 different factors, exactly 2 for a prime, and a composite number has 3 or more factors. Okay? So, in the following table here, we list the factors of the first 10 counting numbers. And if we look here, the numbers 2, 3, 5, and 7 have exactly 2 factors. So those are what we call prime. So if we look at these, 1 only has 1 factor. So, we'll talk about that in a second. He kind of sits by himself. We look at 2. The only 2 numbers that divide 2 evenly are 1 and 2. 3, same case there. The only things that divide 3 evenly are 1 and itself. 4 has 3 factors. 1, 2, and 4 all go into it. So basically remember what our factors are. They're the numbers that we multiply together to get another number. Or if we look at it the other way, they are the numbers that will divide a certain number evenly. So in this case we can multiply 2 times 2 to get 4, but also 4 can be divided by all 3 of these numbers evenly, so we would get a whole number. 5 is also a prime, because only 1 and 5 will divide that evenly. 6 has a bunch, can be divided by 1, 2, 3, or 6. 7 is a prime number, because it only has 2, exactly 2. 8 has a bunch, 1, 2, 4, and 8. All those will divide 8 evenly. 9 has 3, 1, 3, 9, 10, 1, 2, 5, and 10. So, if we go back up here to 2, 3, 5, and 7, they all have exactly 2 factors, so they are prime numbers. Alright, and on the side here, like I said, note, 1 only has 1 factor, so 1 is neither prime nor composite. Okay? So, 1 is the loneliest number here. Alright, so, here's our definition then. A prime number is a counting number greater than 1 whose only factors are 1 and the number itself. So when we looked at, say, the number 3, 1 and 3, or 1 and itself, were the only 2 that were factors. So, if we list, it says make a list of the prime numbers that are less than 16. Well, let's look at all of them, 1 through 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now it says less than 16, so we're not including 16. We remember that 1 is neither prime nor composite, so that's not going to make the list. 2, the only 2 factors that go into 2 are 1 and 2, so that's a prime number. 3, the only factors that go into that were 1 and 3, so that is a prime. 4, we knew that 1, 2, and 4 would divide that number, so 4 is not making our list. 5 was a prime number. Hey, Mr. Ellingson, how are you doing? What's that? I'm recording now. It's alright. I will find you afterwards. Alright, 6, also a composite number because 1, 2, 3, and 6 go into it. So we will not include that. 7. Only 1 and 7 go into it. 7 is a prime number. I apologize for the interruption. Number 8. 1, 2, 4, and 8 also will all divide it, so no. 9 is composite because 1, 3, and 9 go into it. 10, 1, 2, 5, and 10, no. 11. Only 1 and 11 go into 11 for dividing. So that's a prime. 12? Nope. So we should see a pattern now. Every even number except for 2 is not going to be prime, because 2 can always go into an even number. So we can automatically get rid of 14 there. And 13 is a prime number. So just remember that. The only even prime number is 2. So any even number after that will be composite. And 15, that is also composite because 3 and 5 also go into it besides 1 and 15. So here are our first, let's see, 1, 2, 3, 4, 5, 6 prime numbers that are less than 16. All right. You'll have to get used to me checking my time because my videos can only be 15 minutes long. So if I have to go over, I'll stop it at 15 minutes and do a part 2 after that. Alright, so I will be checking the time here pretty quick. Alright, list the factor pairs of each number. Okay, so if we look at 16, this is how we do this. 16 has a certain amount of factors. I know that 1 and 16, if we multiply those two together, we get 16. I know that 2 goes into it, so 2 and 8, 2 times 8 will get us to 16. And I also know that 4 will get us to 16. 4 times 4 anyway. So if we look at this, we get a little rainbow here. 1 and 16, 2 and 8, and 4 and 4. So those would be the pairs. If we wanted to list them, it would be 1, 16, 2 and 8, and then 4 and 4. I would be okay with the rainbow chart. I think that's fine. 17. Well, the only two that go into 17 or divide 17 evenly, or multiply to get 17, that are whole numbers anyway, are 1 and 17. So 17 then is a prime number, only has 2 factors. 18. 18 has a few. We've got 1 and 18. We've got 2 and 9. We've got 3 and 6. Any other ones? Nope, I don't think so. So we've got 1 and 18, 2 times 9, 3 times 6. So there we go. Those would be the pairs, the factor pairs for those numbers. And I will check my time here, just to make sure we're okay. Alright, we're doing alright right now, so we'll move on. Alright, now list the composite numbers between 40 and 50. Now it says between 40 and 50, so we're going to be looking at 41, 42, 43, 44, 45, 46, 47, 48, 49. Alright, remember right off the bat, every even number will be a composite. So we know that this one will be in there, this will be in there, this will be in there, and this will be in there. All those will be in there because they are at least divisible by 2. So we know that's the case. 41, 41, I believe, doesn't have, I think it only has 2 factors, 1 and 41. 43, I believe, is the same way. So I believe those are prime, and I'll double check that in a second. 45, I know that 9 times 5 is 45, so more than 1 and 45 go into it, so that's composite. 47, I believe that is also a prime number. I don't think anything else can divide it other than 1 and 47. 49, we know that 7 times 7 goes into that, other than 1 in itself. And I would like to double check here quick, just to make sure that those other 3 are prime numbers, which I'm pretty sure they are. But I've been wrong before, so I want to make sure. So 21, we'll look here, and this page, 42, 42, 44, 45, 46, 48, 49. Looks like we've got them all. So these would be your composites. These are primes. They will not make your list. So 42, 44, 45, 46, 48, 49. Those are all your composites between 40 and 50. Awesome. Alright, now prime factorization. It says every composite number can be composed or formed by multiplying 2 or more prime numbers. So here we show each of the first 9 composite numbers written as a product of prime factors. So each composite number has its own special prime factorization. We'll look at all these. 4 can be broken down into 2 times 2. These are both prime numbers. 6, 2 times 3. Those are both prime. 8, 2 times 2 times 2. All primes. So basically these are all, let's see, your first what? First 9 composites written as with their prime factorizations. One thing that I'm going to say is that usually when we write a prime factorization, we don't leave it in this form. We don't just say 2 times 2. We would say 2 to the second. Here for 8, we would say 2 to the third. And here would be 3 to the second for 9. If we look at 12, that's 2 to the second times 3. That's because we're multiplying 2 2's. So that's where the second comes in. And then we have another 3 there. And over here for 16, 2 to the fourth, because we're multiplying 4 2's together. So these would be your typical, if you have more than one number being multiplied that's the same, you would put it to a power. All the rest of these are okay. 2 times 7 for 14, 3 times 5. So every composite number has its own special, actually every number has its own special prime factorization, and actually it's used in everyday society. Think of like passwords for anything really, or bank accounts, credit card numbers. They need to make sure that nobody has the same credit card number or savings account number or anything like that. Everyone gets their own special number. So that's how they kind of decipher things like that, because they know that every single number has its own prime factorization. So it's got a special little code. So it's used in things like that, and I think that's pretty cool. And I need to check my time, see if I need to stop here. Alright, we've got a couple minutes here. So let's see. Yes, these are prime factorizations now. So we won't have time to get through this, so I'm going to stop it now and we'll start with part 2 next.